In a world captivated by criticism and negative clickbait headlines, it's easy to overlook the scope and power of technologies propelling us forward. At Tech Optimist, we delve into the vibrant intersection of technology and entrepreneurship, shining a light on innovators who are building a better future. As members of the most active venture capital firm in the United States, our unique vantage point offers us insights into the real-world impact of technology. Join us as we explore, celebrate, and contribute to the stories of those creating tomorrow.
Welcome to the second episode of the Tech Optimist podcast. We have 3 blocks for you today. In the first, we're talking about nuclear energy with one of our young associates, Drew, interviewing a founder. In the second block, Naren and I again have a chat about what's going on, what's buzzy in the venture capital community. And in block 3, I speak to another one of our founders, CEO of Nanopath, a company she founded with a classmate while she was getting her PhD, who's doing some very exciting work. Enjoy the show. As a reminder, the Tech Optimist podcast is for informational purposes only. It is not personalized financial advice, and it is not an offer to buy or sell securities. For important additional disclosures, please see the text description accompanying this episode. Okay, here we are with Block 1 and the conversation between Drew and Matt.
Hello, everyone, and welcome to our video series on some of the great founders, industries, technologies that are taking place across the US and across the world. I'm here with Matt with Aalo Atomics. Matt is one of the smartest and most innovative and thoughtful founders I know in the space of nuclear energy, and really appreciate having you on, Matt.
Thanks so much for having me. I'm excited.
Fantastic. Well, today we're going to dive into a couple of topics around nuclear. We're going to tackle some misconceptions. We're going to talk about what's happening right now, what the future may look like. And this is an area that we're really excited about here at Alumni Ventures. So I think a great place to start, Matt, would be just why should people care about nuclear? Why should people be researching and learning about kind of this energy source, this energy storage source? And how does it stack up against other sources of energy that we may know in the world today?
Yeah. So for me, I studied engineering and physics. So I kind of had a background in understanding the science behind, solar and batteries and fission and fusion. But it wasn't until the past few years when I started really diving into the political and economic and kind of more mass psychological sides of these things. And the more I looked into nuclear, the more I felt like it was just essentially the most misunderstood energy source out of them all by a long shot. I've almost never seen something where there's such a huge disparity between the public perception of something and a lot of the realities. And so, if we kind of look at the different energy sources one by one, all the others they're fine, they're decent, but nuclear is just kind of so much better in all these different interesting dimensions that people don't really understand. So, solar and wind, these are great, they're clean. However, they don't work everywhere and they don't work all the time. And so if you're at like a more northern latitude or somewhere where it's cloudy fairly often, it's really hard to build economical utility scale plants that can compete with, thermal baseload style energy sources. If you're in Australia or California or even parts of Texas, then solar can be great, but it does have these limitations. And if you want to make it baseload, you've got to do overbuilding and storage, and it just gets complicated. So there's that. It's not quite a silver bullet as many people would have you believe. And then you've got things like obviously oil and gas. Oil and gas is actually pretty cheap and reliable, but as we know, they don't really take accountability of their waste. They basically just spew it out into the air, and for some reason we're all cool with that, which we probably shouldn't be. And obviously with things like climate change or smog and hospitalizations with asthma, that's just been something that's becoming more prevalent in the general psyche as a problem. And that's definitely a major thing that's driving a lot more attention to nuclear. And then you've got things like geothermal or hydro, which again are good. They're fine, but they're kind of limited based on geography. So if you're not next to somewhere with really fast moving water or some kind of magma pocket close to the surface of the earth, then it's kind of tricky. And we've already tapped out quite a few of those locations. So with nuclear, it produces clean energy. It produces that energy whenever you want it. And contrary to popular belief, it can do that very economically, and it's already statistically just as safe as solar or wind. So to me, nuclear is just this insanely cool underdog that we should be leveraging much more. And yeah, that's my thought on that.
No, it's fantastic. And it leads to this next question of, it feels almost, it's this underdog kind of like energy source. It's this, sleeping giant. I think we feel like, that know this space. It hasn't always been that way, right? It's definitely an industry that's gone through some rocky periods, both like public perception, regulation, policy. What's different about right now? What's different between, our nuclear and our grandfather's nuclear? And then what pieces of that, you touched on this, but what pieces of that kind of made it so exciting for you to jump in with the company that you're building?
I think you're right to point out nuclear has gone through a bit of a roller coaster with regards to adoption and public perception and so on. And for those who don't know, so nuclear energy research began in the 40s and 50s, and we saw the first deployments in the 50s and 60s. And that was kind of the dawn of the first atomic age. So we saw roughly 52, 53 different test reactors built at Idaho National Lab to explore nuclear technology and learn. And then during the slowdown of nuclear in the 70s, 80s, and 90s, INL, they pared that down to 3. So it went from 52 or 53 down to 3. And what we're seeing is right now there's a resurgence, a start of a second atomic age. And I think this is driven by a few things. So on the one hand, you've got people increasingly realizing that their fear of nuclear power might be a little bit misplaced. Fear of nuclear weapons is totally valid and fair, but people are just kind of now realizing just how different and separate these two things are, nuclear energy and nuclear weapons. And not only that, but we're also realizing that climate change and decarbonization is increasingly pressing. And nuclear is just such an obvious, incredible solution for that. And we've just been ignoring it. And by the way, not everyone has been ignoring it. So Ontario fully decarbonized their grid in the 70s and 80s. Obviously, France also did, and they did an amazing job with their build out. And then you've seen other places that have tried to go, all in on renewables like Germany, and that hasn't quite worked as well just yet. So that's essentially what's driving it. The other side is also on the political side, we've seen a huge amount of momentum towards nuclear. So at the COP climate conference 2 or 3 years ago, nuclear was not even mentioned. But this past year, there were 20 countries that signed on to triple their nuclear capacity by 2050. So we're seeing the governments respond to the public shifting tides of perception. And I think what in large part drove a lot of this is a small group of nuclear advocates. You've seen different folks, down to groups of 5-10 people who have saved entire gigawatt scale nuclear power plants. And they've similarly been, voicing their opinion about nuclear quite loudly on, social media like TikTok and Twitter or X, YouTube, you name it. And there's a really strong change in the tides of perception just based on that small movement alone. So a bunch of these things are changing, and I think nuclear is in for a pretty interesting expansion period in the coming decades.
Yeah, no, it's fantastic. And you touched on, this changing both the political landscape, but then also public perception. And I want to just address some of these kind of public pieces head on. When you talk about nuclear to a layman, to just average person, the first concerns are safety and waste. To the point that I'm at now, and I kind of understand this industry, I have pretty good answers there, and it was a total shift in kind of my mindset on nuclear. But can you just talk about that? Because those are the biggest fears for, I think, a lot of people. Maybe they go past an old reactor, They're like, thank God I don't live near this, right?
Yeah.
But safety and waste has changed and not changed in a lot of ways, but the perception is different than reality here.
Yeah, exactly. I think it's important not to dismiss people's fears as meaningless, but at the same time, it's important for people to kind of look to the numbers and not just rely on hearsay or their emotions about certain things. So, the first thing to point out is nuclear is statistically as safe as solar or wind. If you look at it on a deaths per kilowatt hour basis, which is kind of morbid, but it's a good way to look at it. But really, there's kind of two main sides to people's fears about nuclear. The first side is the waste, and the second side is meltdowns. And so I think, the waste side actually is a little bit more of a misunderstanding or misplaced fear. I think the fear of meltdowns can almost be rephrased as a fear of relocation or a fear of impacting the environment, because it might, surprise people to kind of realize that out of the three major nuclear accidents people have heard of, the past two, nobody died. This is Chernobyl, Fukushima, and 3 Mile Island. In 3 Mile Island and Fukushima, nobody died. However, just the whole idea of a relocation, as we saw in Fukushima, kind of turns people off. And obviously, we want to get around that. But with the waste issue, this is what's really interesting. So the first point is there's such a small amount of nuclear waste. So you take all the waste ever produced in the history of nuclear power worldwide, and it all fits on a football field stacked 10 meters high. This might sound like a lot, but if you compare this to oil and gas or something, like if you took out all the waste that industry has ever produced, it would fill an entire city, and it would be like a mountain stacked like as high as Mount Everest. So this is a huge, huge thing, and if you've ever gone to see nuclear waste in person, you're kind of left saying like, is that it? And it's not some green goo that's leaky and hard to contain. It's very easy to contain, and you actually want to keep it on site because most of the energy content is still in there. So nuclear waste is essentially like taking a bite out of a sandwich and setting it aside. 95% of the energy content is still in there. So we actually don't want to go and bury it deep beneath a mountain or send it off into outer space. We want to keep it close by because it's so easy to handle. There's such a small amount of it, and there's actually good resources in there to use again in the future. So the waste issue, I think, is interestingly a bit of a talking point. You might ask yourself, why do we fear waste if all that is true? And I think the waste was actually a bit of a talking point contrived by people who wanted to end all things nuclear. They wanted to end the weapon, and they thought, if we're going to end the weapon, we have to end the energy source. And it turns out that's just not true. Both that assumption about ending both and throwing the baby out with the bathwater, but also the assumption that waste is quite dangerous. So that's my take on the waste issue. But I think the fear of meltdowns, even though they're very uncommon, I think is valid because you don't want to, even if it happens, once every 20, 30 years, you don't want to have to relocate. And so what we're doing at Aalo is we're trying to make reactors that essentially are, relocation proof. So if there's anything, obviously technology can never be 100% perfect, but what you can do is engineer the system such that if there's anything that goes wrong, anything that happens is just contained in the building. And we're looking forward to proving that out in the next couple of years with deployment and demonstration of some test reactors.
That's fantastic. And I mean, if we are as interesting as I think we are, and people like go want to learn more about nuclear after, listening or watching to this, one of the things they'll see in a lot of these kind of advanced reactors or new reactors is the term meltdown proof. And you guys are looking at it as kind of relocation proof. There's the term meltdown proof. And I think it touches on maybe this broader question of, what's happening in nuclear on the reactor side today with some of these advanced reactors that maybe wasn't even technically possible, a few decades ago, where these reactors don't necessarily look the same as the reactors that you picture in your mind or you see in media. Talk a little bit about kind of the landscape and maybe some of these technical advancements that have done things in the way of efficiency and safety, or even waste, even if it's not this kind of huge problem that many people think it is.
So yeah, first I'll address the fuel side. So our reactors are going to use a fuel called uranium zirconium hydride. And so this is a really interesting fuel that's often used actually in university research reactors. So people don't often realize there's 30 of these things around the US on university campuses. And students walk by these things without realizing they're walking right next to a nuclear reactor. And the reason they don't know is because there's not a big concrete dome over the reactor. And the reason that is because the fuel is so inherently safe. So the students are allowed to essentially try to make the fuel melt down, and they can't because the fuel has an inherent physics property where the hotter it gets, the less reactive it gets. And so this is the fuel that we're using for our reactors to help simplify some of the civil structure and shrink down that engineering and cost to a physics level. But you might ask yourself, why did we not use this type of fuel for other reactors around the world today? And the reason is because this fuel is finicky. So all the water-based reactors around the world, they aren't able to take heat away from the fuel fast enough. And the fuel basically shuts itself off too quickly. But with our reactors, because we use liquid metal, we're able to take that heat away super quick. When you touch a metal, it feels cold to the touch, not because it's actually cold, but because it's taking the heat away from your hand very quickly. So by using liquid metal with this fuel, it's an amazing combination for our reactors because it's simultaneously incredibly energy dense, which is great for economics, but also incredibly inherently safe, which is a good thing on its own, but also good for economics because you shrink down those safety systems. In terms of other big differences with reactors today versus the reactors of the future. So if you look at utility scale nuclear, 60 to 80% of the cost is capex, and a large chunk of that is interest. And the reason for that is because these reactors take 5 to 7 years to build in a best case, and you have to borrow a lot of money, and it compounds year after year after year that you don't make revenue. So there's this vision in nuclear where if instead of building 1 or 2 huge plants, you build 10 or 20 much smaller reactors, then you could start to make money much faster because these would be much quicker to install. And for the same reason that your Tesla doesn't have one big battery cell, it has hundreds of small ones. If there's an issue with one small reactor, you can keep the rest operating. It helps with redundancy and a bunch of other stuff. The challenge, because this is not an easy thing to do, is this might actually save you a lot of capex, but then inflate your operational expenses, your OpEx. And so the engineering challenge is how do you automate the maintenance and refueling and so on and share turbines such that you keep both sides of that equation low. And maybe a good analogy for this is SpaceX. Everyone knew that a good way to lower the cost of rockets is to not throw them away, just reuse the rocket. But it took SpaceX to come along and actually prove it and do it. And similarly, in nuclear, lots of people have this idea of doing these SMRs or microreactors for utility scale power, but no one has come along and actually delivered on that yet and proven just how much you can lower economics with that solution. So if you ask me, that's a possible path for the future of utility scale nuclear that we might see unfold in the coming decades.
So it's almost this kind of distributed network per se, right, of smaller reactors that cost less to build. They're faster to build. So if you are taking out financing on it, those interest payments don't, add up the way they would with these large scale reactors. Is this leading towards a future where there are small reactors, on top of hospitals or apartment buildings? What is this kind of going towards, or is this still something that's going to happen for the majority of Americans and people worldwide, still behind the scenes?
Well, yeah, I think you kind of touched on what might actually happen first, which is eventually we might see these utility scale plants leverage this solution. But the problem is utilities are very risk averse and very slow moving. So, they do not want to take a big risk because that can be a balance sheet risk for the entire entity. And so where we might see a lot of these microreactors deployed first, and certainly the markets that we're targeting first, are the long tail of behind the grid applications that are much like what you just said. So that could include data centers. That's a huge growth area. I think I heard of a data center for an AI training facility that will be a gigawatt, which is crazy. That's like 1 million homes worth of energy. and then a bunch of other smaller data centers for internet and other types of machine learning. And then there's also, for example, EVs. So if you imagine, if we're actually going to electrify all the vehicles, that's a huge, huge challenge. You would have to double or triple the entire grid to power all those cars and trucks and buses. People don't realize, just how much more energy that would require. Right now, EVs are still a very small fraction of cars on the road. And secondly, this is a distributed energy challenge. This is not a centralized challenge. So cars on the road, there's a network of roads all around the country. And so you want to have little microreactors that are just as safe as university research reactors all along the interstate. And that also saves you building a ton of new centralized generation capacity. And it saves you building a ton of transmission. And, funnily enough, people have NIMBYism about everything, not just nuclear, but even simple old transmission wires. So to us, this is another major application. And like you said, maybe one day hospitals or local neighborhoods, even remote communities, desalination plants. I mean, the list goes on. There's a pretty thick, long tail of applications. And I think as utilities see this get deployed in the next 10 years, we're going to see much more utility scale applications as well.
Gotcha. And I want to kind of bring this into a lot of this is there's some political motivations here. There's obviously regulation, there's policy. The sentiment there is changing. I want to put this in almost a geopolitical context. What's kind of happening across the world? You mentioned places like France. You've mentioned other countries and regions that have maybe made more of an effort to bring nuclear into their grids, or places that have, refused it. Where does a country like the US kind of stand globally in its nuclear development, or its kind of interest in bringing nuclear, into our energy grids?
So the US is definitely still doing pretty well in terms of the number of reactors it has live, although there has been an unfortunate set of plants which have been attempted to be closed, and luckily the nuclear advocates have kept those alive. But internationally, we're seeing Russia, China, South Korea are kind of creeping ahead in terms of their ability to deploy anything from large-scale traditional nuclear plants, which were kind of invented in the US, all the way to what's called advanced reactors, which use different types of coolants and fuels to achieve different characteristics like what we talked about with inherent safety. So these other countries are definitely getting ahead, and we have to make sure that we catch up. I mean, one big part of this is the research reactor angle, because for schools in the US to train the next generation of nuclear operators and scientists and nuclear engineers, we need those research reactors, and probably need more of them. But certainly, in a lot of ways, we're playing catch up now with those other countries. Yeah.
Fantastic. Cool. So we're still kind of a leader, but like everyone is moving up. I think people are waking up and kind of understanding that this needs to be, a crucial piece of this broader energy transition. It's not a knock against solar or wind or hydro, right? It's all kind of be a piece of this big puzzle. But there are definitely advantages here that are really exciting.
I think one other thing that I'd love to touch on is, I think a lot of people don't realize just how little progress we've made in decarbonization. So we see news articles about how solar deployment or wind deployment is doubling or tripling, how many batteries we're selling. But if you look at a graph of the grid, it looks somewhat promising. You say, oh, look, we've got 20 or 30% decarbonized grids globally. But the grid is a very small fraction of energy that we use globally. And energy, if you look at that, only 5 or 10% is clean. The rest is still natural gas, coal, and other oil and gas forms. And this is just a huge, huge challenge that people don't really understand how much we still have to do. So it's great that we're getting accelerating, solar and wind and more batteries, but we need more of everything. And like I said at the start, nuclear truly is the most versatile solution to this problem. So I think we need a lot more of it.
We indeed need a lot more of it. And that leads to kind of the final topic here is there's a handful of companies that are really kind of pushing the envelope on what it means to kind of create these scalable reactors, do it efficiently, and do it sooner than maybe expected. So tell us kind of the origin story of Aalo, where you guys are at now, and what the long-term vision is for the company and how it's going to have an impact on kind of this entire nuclear energy transition.
We identified a regulatory catch-22 that has been somewhat slowing down a lot of the advanced reactor deployments worldwide. And what that is the regulators, they want you to have nuclear test data before they grant you a license, but you can't get that test data without a license. And so what we identified is while a bunch of companies are trying to build scaled down test reactors, the difficult thing is none of these will be revenue generating. And so what we found is there's actually a government reactor called MARVEL, which is the first new advanced reactor being built in the US in decades. And this is going to be finished construction this year in a matter of months and turn on, go critical early next year. And recently that team achieved a historic approval. They were the first new reactor design the DOE has ever approved for construction since the DOE was formed in 1977. And we actually recruited a bunch of the core people from the MARVEL team to Aalo. And what we're doing is we're building a scaled up, more commercial version. And so the Aalo 1 is our first reactor. This is a 10 megawatt electric, 30 megawatt thermal microreactor. And this will be essentially starting construction on a commercial revenue generating version within 3 years, which is the same time frame that essentially MARVEL achieved in the government setting. And so that's the approach we're taking. The initial markets we're going after will be data centers, desalination plants, decarbonizing oil and gas processes. And eventually, with our second product, this will be the Aalo 2. That will be 100 megawatt electric, and that's what we'll go after the utility market with. Because we think that'll achieve just the right balance between economy of scale and economy of numbers. And so that's the approach we're taking. And we'd love to chat with anyone who's interested in diving into our technology or collaborating or joining the team.
Yeah, that was great. I do want to push on one piece, not in a bad way, but just to further kind of like have people get an understanding of this, and maybe we can like throw up an image at this point. But Aalo 1 and then maybe even Aalo 2, like size, like just contextualize this for people. Like how big is this going to be, at scale? And then it's like 10 megawatts for, electric, and then it's 30 thermal. Comparisons, like what would it take to kind of generate that level with other sources?
Yeah, that's a good point. So physically, the Aalo 1 reactor, the 10 megawatt electric one, will fit within a shipping container. So it's very small. The overall plant size will be less than an acre, including all the other equipment and so on. So this really is kind of a parking lot sized reactor. And this could power about 10,000 homes. So it's about that kind of size. And the Aalo 2, the interesting thing is the scaling of energy is more than linear with the scaling of physical size. So the reactor, the Aalo 2, the 100 megawatt electric, even though it's 10 times the power output, will be only roughly double the physical size. And so that's another key point. And what was the other question? It was in terms of, comparison. Yeah. So, if we compare what the Aalo 1 is replacing, this is essentially something that fits in a shipping container, yet can replace a square kilometer of solar panels. And keep in mind, with those solar panels, they might not work as well when it's cloudy or wouldn't work at all when it's nighttime. And so there comes all these complications where if you really want to compare apples to apples, you'd have to do extra solar panels and batteries and a complex system versus this one small shipping container sized reactor that's just as safe as a nuclear reactor that's on a university campus. So that's really what we're trying to achieve with the Aalo 1.
Fantastic. I don't know how people can't get really excited about this, to be able to kind of create power at that level, and do it in, a shipping container size essentially. And then like on this acre of land, is incredible. So you guys are crushing it so far and really looking forward to seeing what happens in the future. Matt, this was great. I appreciate you taking the time. Is there anything that we didn't jump into today that you feel is important, that our community knows?
I think we touched on it all. I think those are great questions, Drew. And yeah, really appreciate you having me on.
Awesome. Thanks, Matt.
Hey, everyone. I want to take a quick break and share more about Alumni Ventures and our U.S. Strategic Tech Fund. AV offers smart, simple, and accessible venture portfolios for individual investors. We build diversified portfolios with low minimums, co-investing alongside renowned lead investors. It's a strategy that has mobilized over $1.3 billion from our community of now more than 10,000 individual investors. With our U.S. Strategic Tech Fund, you have the opportunity to invest in technologies that are critical in bolstering U.S. national security and economic prosperity. We prioritize 3 key areas: homeland security, cyber AI and digital strategy, and lastly, space innovation. By investing in companies that are innovating in these areas, our goal is to enhance resilience in emerging threats and to support early stage ventures that will encourage sustained growth and technological progress in the United States. If you'd like to learn more, click the link below or visit av.vc.
Okay, here we are in block 2. I'm having a conversation with Naren. We're talking a little bit about NVIDIA, what's going on with kind of physical infrastructure and a trend towards sovereign technology, and just the enormous amount of tech advancements taking place in the healthcare field right now.
Hey, Mike, welcome on.
Hi,
Excited to chat about 3 things happening in tech today. Let's start with the NVIDIA GTC conference, GPU Technology Conference, happened last week in the Bay Area. It's been called the Woodstock of AI event. A lot of technical breakthroughs. Curious what your key takeaways were and where you see sort of this groundwork that NVIDIA is laying, where you're seeing that playing out in the next few years.
No, first, it's really nice to see, NVIDIA having its day, for sure. I mean, good company, been around a while, worked and has done really phenomenal things. And yeah, I think it was a pretty apropos description of the event. Yeah, I mean, I think for me there was, obviously kind of introducing kind of their next generation GPU, pretty impressive, pretty powerful. But to be kind of expected, I would say. For me, I think I was struck by the partnerships, and it was kind of a who's who of, deals and partnerships that they're doing, that this is a company that is working with the most powerful companies on the planet in a very kind of deep embedded way. Obviously, Google, Microsoft, Amazon, Apple, they're with them all. And so that is really pretty striking, pretty remarkable. Some of the things they're working on just really, I think, point to the next generation of technology on this planet. And so, very, very exciting. I think the robotics story I thought was also really interesting. I think one of the real exciting things about this time is, not only do we have 1, 2, 3 major technology breakthroughs coming together, but they're interacting with each other. And so this idea of robotics and AI and augmented reality and virtual reality and, just really, really exciting. But, I was a little surprised, but I really was, impressed. And, I think we've talked about, we have an AI fund. We do a lot of robotic investing here. And, I think we're looking at combining those 2 funds in our next vintage, because we do think there's such great opportunity kind of in both streams, but really the combination is also really exciting when you can combine hardware, software, real innovation can take place. So, I think that, and again, I just think the blueprint for next generation data centers where, again, just kind of picks and shovels, infrastructure, compute really being one of our currencies. I just think we're talk about infrastructure and the ability to kind of build on those things. Really exciting to think about compute at scale with these new data center frameworks. So those were some of my big takeaways. I don't know. Do you have any thoughts?
No, absolutely. I think I was actually surprised to see NVIDIA getting their hands dirty into many different technology areas. So we always knew that they're into compute and AI, and that seemed sort of a linear extrapolation to make. But they're going into an integration with, through their announcement of Omniverse, going into the augmented reality space, integrating with the Apple Vision Pro, and that's its own technology platform that's going to emerge. Robotics, you mentioned. The other thing is, which I didn't expect, is their 6G research platform, which is the successor to 5G, and trying to be just ahead of the curve in terms of having connected devices. I mean, we're going to see smartphones, we're going to see our smart glasses, even our beds and sofas are going to be connected to the internet to provide all sorts of insights. And NVIDIA is really putting together infrastructure there. And the last piece for me was in healthcare. Yeah. They announced a partnership with Hippocratic AI, which is a startup funded by A16Z, to create an empathetic healthcare bot. I'm curious about your thoughts there. How do you see medicine and AI interacting in this way?
No, it was really impressive. That was for sure. I wish I had touched on that, but that was, yes. I mean, I think healthcare is dead center in this space. I mean, you think about, what medicine is. It's sensors, data, frameworks. I just think I think it is a great opportunity for innovation for sure. And I think it lends itself to kind of some of these things we've been talking about. And I think it's a great platform for innovators to start companies. And I think some of these platforms are really going to accelerate it. And I think, a generation from now, our healthcare experience is going to be totally different. So very optimistic.
Yeah, absolutely. And, we talked about one side of tech infrastructure through NVIDIA and wanted to move to the second topic, which is our physical infrastructure in the US. We've seen what's been happening with Boeing. There was a bridge in Maryland that collapsed a couple of days ago. And, in terms of the personal data of our citizens with regard to TikTok, a lot of things happening there. Curious to get your thoughts on sort of, it's a broad question, but across those items.
Yeah, I think the big picture on that and what I'm hearing in the industry is, I think, a shift in the perception of kind of sovereign technology. If I don't know if that's a term, but I think we've decided as a society in the United States here that there are technologies that we need to be great at and control to some extent. And the necessity of, yes, the physical infrastructure of, logistics and aerospace, but we're talking about things like chips and cybersecurity and energy technology, all the innovations going on with drones and military innovation. I think there are, now a dozen key technologies that, I know as an American citizen, I want to be sure that we're really, really good at. And I think over the last year or two, and again, I don't take this as, people being against free trade and, the value of us having an open world economy and being cooperative with every nation that fairly wants to trade with us. I think everybody's everybody with common sense is there. But I do think there are things where, there are bad actors in the world. And whether those be individuals or groups or nations that that our citizens are going to demand that our country has excellence and is innovating. And, we are such a entrepreneurial powerhouse in the world today that there is no excuse for us not to be leading in all of these spaces. And I think it's strategic, and I think it's important, and I think that is starting to become accepted in more and larger circles. And so, I think I think you're going to see a lot more, Naren, in this space. Obviously we had the CHIPS Act, which basically said, we have to control silicon and be really good at it. And just the way modern civilization is, modern life, economic power is power, at least equal to, just military might. And so the definition of economic power increasingly is about these technologies. And, I am cautiously optimistic that people get that, but I do think we need to continue to invest in and innovate and encourage entrepreneurship and cooperation, frankly, between the public and private sector to be sure that, our companies are leading the way in cybersecurity and in AI and in chips. And by saying, and it's a tricky balance because we all want smart guardrails, but, overregulation is just going to push it offshore. And you do not want some of these technologies in the hands of bad actors. So I do think, this, in kind of old economy ways, this bridge disaster points to what I think is actually even a more important, which is, being really good at really important stuff.
For sure. And, on that point, A16Z has launched their American Dynamism Fund a few years ago. We've invested in a number of military defense related startups, cybersecurity, and we have our strategic tech fund offering the ability to get into these amazing transformative companies for the accredited retail investor. So maybe if you just want to share a couple of words on that.
Yeah, I mean, we're in the very early stages of putting together a strategic fund that is designed to invest in these kinds of ventures, really a diversified portfolio, co-investing alongside well-known firms like is in our core strategy, but really focused around a dozen of these key pivotal technologies because we just believe in it. We believe that it's obviously good investing, smart investing, but, when you're able to do well and do good at the same time, that's something we get really excited about and our teammates get very excited about. And yeah, more to come on that story, but that's something definitely that we're going to put our money and time where our mouth is in believing in it.
Yeah, no, thanks for sharing. And maybe moving on to our third and last topic for today, there's a lot happening in the world of healthcare. We briefly touched on healthcare and AI, but we know that there's a doctor shortage in the US. The cost of healthcare has been rising historically higher than the cost of inflation. And meanwhile, there's a bunch of new diseases that keep propping up, but at the same time, there is an optimistic viewpoint to this, is that the new technologies like AI are going to help us determine treatments and actually find treatments and the most effective way to deliver those treatments, even without potentially side effects in the future. And we're seeing that across blood cancer, brain tumors, sickle cell disease, etc. What are you seeing from your vantage point?
Yeah, I mean, I just think if you're paying attention, it's almost weekly now that there is a really exciting, substantively exciting announcement in the area of healthcare. There was just one example of that is just came out of Massachusetts where, using CRISPR technology really took a pig kidney and was able to kind of modify it enough to make it be able to be put into a human who is having kidney issues. And that's dialysis, a couple times a week is really a tough treatment option that unfortunately tens of thousands of people have to live with. And so just a shortage of good kidneys, again, not at scale yet, but really promising. There was also some, a really interesting thing with brain tumors coming out using, CAR-T technology, where you're basically kind of using your own systems and bodies to target cancer and using your own immune system. And you look at the cross sections of the X-rays of the tumors, kind of before and after, and again, just striking things. And frankly, hitting close to home. I lost my grandfather to that specific tumor type, and I think he lived about a year after the diagnosis, and now, again, really promising stuff. We've talked extensively around the company around the GLP-1 drugs and just the potential of those to address kind of chronic obesity in our society. And just looking at the pipeline of drugs that are, just another announcement with another company that had moved to, I think, phase 2 with its pill form of this drug, with really, again, super early but super promising results. And then we're always looking here too internally about, are there ways that we can accelerate change and disruption? Obviously, with healthcare, there's huge and appropriately huge regulatory requirements to, go through the process safely and professionally. But even before you get kind of into the FDA cycle, there is a really, long and at times it seems to be inefficient process getting from the lab, where, the motivations and incentives can be different. So are there interesting ways to bring some of the magic of venture capital and entrepreneurship and the profit incentive and just raw capitalism? Can we bring that more into the realm of healthcare and technology, AI? So I think there's going to be not just promising technologies, but I think there's going to be promising new approaches in this space. There's some good examples with, some individual success stories. A noteworthy one with, I think it's cystic fibrosis, where, there was a nonprofit that really, kind of created a venture arm to their nonprofit. And, I think it's been called like venture philanthropy. And can we combine people's interest in supporting nonprofit research, but using kind of a entrepreneurship, venture capitalism model to really accelerate that? And I think the story there is a nonprofit in the space really funded a bunch of technologies and startups in a kind of a traditional venture model, where they kind of acted as the investor. And one of those turned out to be an enormous success, both financially. I think they eventually sold it for billions and became one of the core therapeutics for cystic fibrosis. So, I think there are some lessons in that case study that I think could be part of our future. I think the ability to kind of always, whenever you can bring markets and capitalism to solving problems, I think it can do wonders. And so I think there's more innovation coming in that space. And, again, our organization and others we work with, I think, are looking at those things closely and want to be part of innovation and solutions in the space. So those are three things from this week that I think are on my mind and on the mind of people that I'm talking to in the industry.
That's great. Thanks a lot.
Appreciate it, Naren. Talk to you next week.
All right. See you later. Bye.
Bye.
Just a brief interruption to tell you a bit about Alumni Ventures and our Doctors Innovate Fund. Alumni Ventures enables individuals to invest in startups shaping the future. We build diversified portfolios by co-investing alongside renowned lead investors. Today, we serve over 10,000 investors who have invested more than $1.3 billion. With our Doctors Innovate Fund, you can invest in a portfolio of around 20 healthcare technology companies. From transformative healthcare services to groundbreaking diagnostics, our founders are paving the way for a healthier future. If you're curious about diversifying your portfolio and helping to drive the next wave of medical breakthroughs, visit us at av.vc.
Okay, in block 3, let's hear from the co-founder and CEO of Nanopath, Dr. Amogha Tadimety. So today I'm talking to Amogha, who's one of the founders of AV portfolio company Nanopath. And Amogha, nice to meet you. And tell me a little bit about your company and where you are in your journey, and we'll go from there.
Sounds great. Well, I'm Amogha Tadimety. I'm one of the co-founders at Nanopath. Nanopath is a molecular diagnostics company that's focused exclusively on conditions that affect women. So we have a novel technology that my co-founder and I invented at Dartmouth that allows for amplification-free detection of DNAs or RNAs, which enables us to look for many, many targets at once in less than 15 minutes. And if we think about today, for most conditions that affect women and most infectious disease diagnostics in general, a patient will go to their provider, they'll give a sample. That sample will be sent to Quest and LabCorp. It'll take a few days. In that time, the patient might be started on a kind of a guess at a therapy. They might be lost to follow-up in the time between they go to the doctor and the result comes back. And so our vision is, can we shorten that entire diagnostic timeline to that 15-minute office window and enable the patient and provider to get really clinically actionable results while the patient is in the office. And we're focused in on urinary tract infections, STIs, vaginitis, a range of conditions relevant to women's health.
Great. Now, this is a deep tech story. So can you go back kind of to the origin? You were getting, I think, your PhD up at Dartmouth, up at Thayer. Was this an area of research for you? How did the company come together?
Yeah, so Allison and I were both up at Dartmouth doing our PhDs at the engineering school. We'd both done a huge actually variety of research before going to Dartmouth, but we're really passionate about trying to develop something during our PhDs that could be turned into a product where we could see that patient use case. And so we were actually in a really unique program that focused on entrepreneurship and innovation in addition to all the rigor of a traditional PhD, and that PhD innovation program allowed us to take courses at Tuck, understand what it is to form a company, have the basics of IP. We were both working on different technologies related to diagnostics. We were actually friends first, and Allison had been focusing on sample prep, which is, how do we grab a rare biomarker of interest out of a patient sample? And I was working on this detection technology for DNAs. And so we met, became friends, and we were like, oh my gosh, imagine if we could, take any complex sample, grab a biomarker of interest, really analyze it to understand what's going on with the patient. Like that could be kind of game changing across diagnostics. And we'd focus on infectious disease. We'd looked at cancer during our PhDs, and we actually spent a lot of time trying to figure out where to go first, especially because our first year of the company was 2020 when the pandemic was ongoing. So there were a lot of different kind of variables to consider, but we spoke to a ton of doctors and patients, lab directors, and really found this immense unmet need in the women's health world.
Where are you as far as what are the next milestones that you're really focused on right now? Where are you from the science perspective, go to market, those kinds of things? You've raised your A round, I believe, correct?
Yeah, so we raised our A round in 2022. At that point, we were a team of 4, and we'd done some really basic pilot studies on both the consumable and a piece of benchtop instrumentation. So in the last 2 years, we've grown the team. We're 12. We have experienced heads of assay development and engineering. We've been working on getting both the consumable and the reader into closer to a go-to-market form. And the key milestone is this summer, we're going to be running a few clinical pilots in a couple hundred patient samples on that system that we know we can make at scale and at cost. So following those pilots, we'll be raising once again to build that go-to-market system and do the regulatory studies in support of approval.
Now, you mentioned you and Allison both have technical backgrounds. What have been the big learnings from the non-science side, the building of the business, the recruiting, the managing of teams? What's been interesting on that front?
Yeah, so there's a couple things. So I think we started this company as scientists saying, okay, we have this technology and we think it's going to be immensely valuable. I think as we've grown the team and surrounded ourselves with people who have done this before, it's shocking how quickly our focus and attention and happiness is directly tied to that of the team. And so I think that's been a huge learning. I think the other thing that's really challenging in diagnostics is that there's this really interesting kind of cycle between target product profile and end user and technology development. So trying to put a lot of the commercial work at the forefront to understand who the end user is, what the requirements are going to be for regulatory approval and for reimbursement, and making sure that's kind of cohesive with our technical strategy. So a lot of the work that Allison and I try to do is to say, what's really important? How do we make sure that those priorities are correctly articulated to our team so that the target product profile is very clear and they know that R&D resources should be going towards the most important product features, which are time, which are the ability to detect many, many targets, and which are kind of the use case, which is that it needs to be in an outpatient setting. It might be a minimally trained user. How do we make sure from the outset that all of the reagents, all of the workflow steps are compatible with that site? So I think that's been a huge area of learning for us, is that I think we couldn't have dived into the commercial work too soon, and actually all of that stuff going into the product as it's being built is hopefully gonna give us a head start as we get out there.
What do you think are kind of the tailwinds to the work you're doing, and what are some of the challenges? Just this point in time. Yeah,
so I think there's obviously a ton of diagnostics companies that cropped up during the pandemic, and a lot of them were focused on respiratory viruses like COVID and the flu. And so I think as those technologies find a home, there's a lot of kind of crowding in the market. I think we have a really lovely head start because we've been focused on a different set of indications, and the value of the technology is significant. But I think that's kind of a challenge, and clearly articulating why what we're doing is different is something that we've been thinking about as we've grown the company. In terms of tailwinds, there's a lot of really exciting movement in women's health specifically. There's this new task force started by Dr. Jill Biden. There's ARPA-H that has this new sprint for women's health. So there's a lot of just motion, I think, understanding that not only is this a huge problem and a set of patients that's been underserved historically, but there's also higher potential returns on investment into women's health. And so I think that's an exciting tailwind. And I think we're seeing that in the clinics as well. So there's all these new women's health clinics that are cropped up that are trying to address holistically the needs of women, from gynecologic care through fertility through menopause. And a lot of these new care models could be amazing partners for us to work with in the future.
No, I also see, and obviously Laura Rippey, who's putting together our Women's Fund, I think we're seeing a sea change in kind of the support of women's capital, women venture capitalists, women CEOs, founders, technologists, starting to create an ecosystem that is serious and powerful. And so I agree with you. What would be an ask that you have for our audience? Is there something, we have a huge community, very varied in their backgrounds. Any particular ask you have of our listeners?
Yeah, so I have a couple things. So we're still actively growing the team. So I think anybody who's kind of talented and interested in this realm, please reach out to me or Allison. That's one thing.
Are you located Yeah,
We're based at the Engine in Cambridge, so we're right in Kendall Square. We have engineering, lab, and office space here. 12 full-time, and then a rotating door of co-ops and amazing interns as well. So
the Engine's a great place to start a business. For sure.
it has everything we need. Like, especially being in diagnostics, like we need the 3D print room, we need the electronic studio, we need the dry lab, and our team is just like running between the different facilities as they work on things. So
people should go check out your website, look at the posting for openings, and if there's a good fit, reach out. Yep.
Well, yeah, that's one thing. And then I think we're also like constantly adding to our board of advisors. So we're looking for commercial advisors specifically who know reimbursement for diagnostics, who know these end user sites. And I think like in the next 6 months or so, we'll be gearing up to do some pilot testing in partnership with some of our end user sites. So I think anyone who has insight into that like clinic world, how they make decisions about bringing on new diagnostics, how they evaluate them for ROI, like that's another kind of big upcoming chunk of work that we would love any connections or advice from the AV community.
Great. How about having a co-founder and a partner? That what has been kind of the biggest rewards? How have you kind of divvied up responsibility? Talk to me about kind of the co-founder experience you've had.
Yeah, I think working with Allison has been just the greatest joy. I think like we were really lucky that we knew and respected each other a lot before starting it, and that we have very, very similar visions for the mission of the company, the kind of team we want to build, the kind of product we want to put out. I think it's been truly necessary to have somebody who sees every piece of the picture the way I do, who's equally good at both science and a lot of the commercial aspects. And I think like we've been doing a lot of things hand in hand, and anything that gets divvied up is purely based on kind of interest and passion for the task. So I think, it's been absolutely a joy working with Allison, and I'm so lucky to have her. So,
well, this company we're very excited about. You're doing important work, making great progress. We wish you continued success, and encourage our audience to reach out and be helpful if you can, because it takes a community to build a business, and you're off to a great start. Better days ahead. So Amogha, nice to meet you, and look forward to meeting you in person soon.
Awesome. Thank you so much for having me.
Hey, everyone. I'd love to take a moment to tell you a bit about Alumni Ventures and our Women's Fund. AV offers the opportunity for individuals to invest in startups shaping the future. We build intentionally diversified portfolios, co-investing alongside established lead venture investors. Today, we serve over 10,000 individual investors who have invested over $1.3 billion. With our Alumni Ventures Women's Fund, you'll have the opportunity to help us invest in fiery female founders. We're starting from a position of strength. AV has already invested in over 350 startups founded, co-founded, or led by women. We see the Women's Fund as a great opportunity. PitchBook reports female-led startups are more capital efficient and exit faster, yet only receive 15% of all venture capital dollars. Join us to invest in female-led startups innovating in sectors like cybersecurity, machine learning, space, femtech, AI, and robotics. Join us in the Alumni Ventures Women's Fund to put your investing capital to back a diversified portfolio of female-led, high-velocity startups as they change the world. If you'd like to learn more, visit us at av.vc/funds/women's.
Thanks again for tuning in to the Tech Optimist. If you enjoyed this episode, we'd really appreciate it if you give us a rating on whichever podcast app you're using, and remember to subscribe to keep up on the weekly episodes. The Tech Optimist welcomes any questions, comments, or segment suggestions, so please email us at info@techoptimist.vc with any of those, and be sure to visit our website at av.vc. Thanks again. Until next time.